So they have given the mass of a satellite and they have given the initial orbit in which it is revolving. And they said how much energy is supplied to the satellite from this, which is already revolving in this orbit. Then it would revolve in a new orbit of what radius? Okay, and the answer should be in terms of r. Try this, all of you. So the question is related to energy and radius of revolution of a satellite. Okay, so recollect those things and try to apply that. Fine. Can one of you tell me the formula for total mechanical energy of a satellite in orbit?
Minus GMM by 2x.
Minus gmm by 2x, correct. So the energy of a satellite which revolves in an orbit of radius x is minus g by 2x. Okay. Now see, they said that it is revolving in an orbit of radius 2r, and after supplying that energy 10 power 4 r by 6, in which new orbit will it revolve is what they are asking. So new radius is what we want. Okay. Now we had discussed this point. Greater the radius of the orbit, greater will be the energy of the satellite. So if you supply energy, the satellite can be taken to a higher orbit. And the energy that you supply, okay, this 10 power 4 r by 6 that is there, the energy that you supply will be the energy difference, okay, of satellite in the final orbit minus energy of satellite in the initial orbit. That's all. So let's say it finally revolves in an orbit of radius x. Then the final energy of the satellite will be this. Let's write it as E final. And initial energy of the satellite is minus gmm by 2 into 2r, because initially the orbit radius itself is 2r. So 2 into 2r. The difference between these two is the energy that you supply. Okay. So E final minus E initial, that becomes minus gmm by 2 into 1 by x minus 1 by 2r. E final minus E initial is the energy that you need to supply. 10 power 4 r by 6. Okay. And we want the answer to be in terms of r. Fine. Now they have not given all the terms that are needed to substitute in this equation, but they have indirectly given them. They give satellite mass as 10 power 3 kg. Now in G capital M, small m is the mass of the satellite. Capital M is the mass of the planet. Now they have not given the mass of Earth, and you are not required to know the mass of Earth also. They have given G. You should somehow make use of that. Okay. G refers to acceleration due to gravity on the surface of the planet. So this is G capital M divided by R square. That value is 10. Okay. They are indirectly asking you to take that as 10. That means G capital M can be taken as 10 into R square. That will help you solve this problem. G capital M is 10 R square. Okay. So sending the minus inside, 10 into 10 cube is 10 power 4 R square by 2. Sending the minus inside, you get 1 by 2r minus 1 by x is equal to 10 power 4 r by 6. After that, you just have to simplify the equation. You will get x in terms of r. Okay. Anyway, this will come with practice only. Like this idea that gm can be expressed in terms of acceleration due to gravity on the surface. That will come with a lot of practice. Okay. The more problems you solve, you'll get used to the fact that small g is gm by r square. Okay. Next question. Try this. An astronaut takes a ball of mass m from Earth to space. See, from Earth to space means from the surface of Earth, it is taken to a very large height above the Earth. Okay. he throws the ball into a circular orbit about Earth. Okay, so after taking it to a certain height, he is giving the ball the velocity required for it to stay in a circle. Means he is giving the orbital velocity. And they have given how high it is taken also. Altitude means height from the surface of Earth. Okay, not from the center. Obviously, 318 kilometers cannot be from the center. So above the surface of Earth, it is taken to that height. So from Earth's surface to the orbit, the change in total mechanical energy of the ball is this much. Okay, this is slightly complicated language. See, when the ball was on the surface of Earth, it would have had some mechanical energy. When it is placed in orbit, like a satellite, it will have some mechanical energy. That change in mechanical energy is this much. They are asking you how much is x. Okay, so solve very carefully. I'll give you 3 minutes. Right. Important. It's important to visualize what is happening first. So let's imagine a planet. From the surface of the planet, the object is being taken, the ball is being taken. So this is the initial position of the ball. It is taken to a certain height. Let this be the final position. And there it is projected with the required orbital speed such that it revolves around the planet like this. Okay. And what all have they given? They have given the height to which it is taken. So this height is known. Radius of Earth they have given. So if you know radius and height, you know the total distance to which the ball is taken. They are asking you the change in mechanical energy. Okay. Change means what? Final value minus initial value. So mechanical energy at B. Okay. At B, it is released in orbit. So you can think of it like a satellite. Okay. You can think of the ball like a satellite. That will give you the mechanical energy at B minus mechanical energy at A is what you need to calculate, or is what is given to you as x into g, mass of Earth, mass of satellite, divided by 21 times radius of Earth. They are asking you to calculate how much is x. Okay, try. Yeah, Vanilla, you unmuted. Any answer?
Where I got
We could only hear till I got. Anyway, type your answer in chat. We'll see. Okay. One of you tell me, do you see any relation between 318.5 and 6370? 637 divided by 2 is 318.5. Okay. So basically, this is radius divided by 20. Okay. So it is taken to that height. And again, this will also come with practice actually. It is easier to solve problems which are given in terms of the radius. Okay. So what we'll do is we'll solve everything in terms of radius only, because the final answer also, if you see, is in terms of radius of Earth. So don't substitute that altitude 318.5 and try to get the answer. You'll be doing unnecessary calculations. There's a relation between those two. So take that height as r by 20. Okay. Now, initially, when it is at A, that is the surface of the planet, the planet and that ball will have some potential energy. Potential energy is minus G capital M small m divided by R. Okay. Potential energy of a mass on the surface of a planet minus gmm by R. Kinetic energy, you will assume it is zero. See, an astronaut takes the ball, right? So the ball starts from rest. So initially it doesn't have any kinetic energy. When it is on the surface of the planet, it doesn't have any kinetic energy. Finally, when it reaches that height, we know the expression for total energy of a satellite. We can use that directly. You don't have to write potential kinetic separately when it reaches B. Okay. You know that it is taken to B and it is released with the orbital velocity. So basically it has sufficient energy to stay in that orbit. And what is the energy required to stay in the orbit? Minus gmm by 2 times the radius of the orbit. Now height is r by 20. So radius of orbit becomes r plus height. Okay. Radius of the planet plus that extra height. So r plus r by 20. 21 r by 20 is the radius of the orbit. 220 goes 10 times, 10 goes to the numerator. So the final mechanical energy is minus 10 gmm by 21 r. Initial mechanical energy is minus gmm by r. You can write it as minus 21 gmm by 21 r. I'm just equating the denominators so that we can easily subtract the numerators. Therefore, energy at B minus energy at A. Minus 10 minus of minus 21 becomes 11 gmm by 21 r. And they are saying this is equal to x gmm by 21 r. So x becomes 11. Simple. Okay. So first you should get that idea that 318.5 is a can be expressed in terms of the radius. Okay. After that, you should know how to calculate mechanical energy of an object, and you can solve. Okay. Try this question. This should be relatively easy. It should be very easy actually. It's based on the speed of a satellite and the radius of the orbit. I want answers from all of you. I'll give you all exactly 2 minutes. Okay. Type your answers in chat. Two satellites A and B go around a planet. So it's the same planet in circular orbits having orbit radii 4r and r respectively. One satellite speed is given, the other satellite speed is asked. So this is related to orbital speed. The formula for orbital speed is under root gm by r. Okay, so speed of A will be under root. Okay, I should not say gm by capital R. It's better to remember it as gm by x. So gm by what is the orbit radius in which it is revolving? 4r. And speed of B will be under root gm by what is the orbit radius in which B is revolving? R. And speed of A is given as 3v. That's all. Okay. Square on both sides. Okay. Squaring is not necessary also. Cancels. You get 1 by 2 here. That's all. So VB is equal to 6V. Simple direct question based on orbital velocity. Okay. Not so direct, but fine.
Sir,
Any doubts?
sir, if they say radii, should we take it from the surface or the center of the planet?
Why will you take radius from the surface? Radius will be taken from center only. Height is to be taken from the surface. Radius should be taken from center only. That is the meaning of radius. Okay. Next question. Okay, I've given you the options also. Like just to give you an see, uh, the final exams that you all are going to take will be objective exams only. Take a look at the options once before you start solving the problem, because if you see the options, you will get to know in terms of what they are expecting the answer. Like you can see there are some options in terms of ratio of radii, and there are some options in terms of ratio of masses. Okay, so you should get the answer in terms of one of these. So read the question carefully. Two planets A and B. This is about planets. Planet masses are given. Move around the sun in circular orbits. So this is an imaginary case, you can say. You should imagine planets revolving around the sun in circular orbits. Their radii are given. Angular momentum of one planet is L, and the angular momentum of another planet is 3L. So you have to think related to angular momentum also. And they are asking ratio of time periods. Okay. So if you know how to express angular momentum of a particle, and if you know how time period is related to radius, you can solve this problem. Recollect those things and solve the problem carefully, all of you. I'll give you all 3 minutes. Type your answers in chat. Any answers?
It's the B option.
Option B. Let's see. Let's see. See, planet, I mean, it is given in the question that planet is going around the sun in a circular orbit. So the equations and all will be similar to satellite going around a planet in circular orbit. And when satellite goes around a planet, we know t square is proportional to x cube. So ta square by tb square can be written as the radius in which a is revolving. That is r1 cube divided by r2 cube. So Ta by Tb, if you take square root on both sides, it becomes r1 by r2 whole power 3 by 2. Like this is r1 by r2 whole cube. You take square root on both sides, r1 by r2 whole power 3 by 2, but that option is not there. Okay, r1 by r2 whole cube is there. R2 by r1 whole power 3 by 2 is there. So both are not correct. So answer can be expressed in terms of r1, r2, but it's not there in the options. Okay, but see, I directly started solving from here. Square of time period of revolution proportional to cube of the radius. Okay, so you are expected to be thorough up to that level. Fine. So time period of revolution of a satellite t square proportional to cube of radius, that you should know comfortably. Okay, this way we are not getting anywhere. But we know that the ratio of time periods depends on ratio of radii. But the two options which are given in terms of radii are eliminated. So we should express this in terms of masses now. Okay. How to relate radius and mass? They have given you a hint in the problem. They have given you the angular momentum. Okay. They said angular momentum of A is L. When an object is revolving in a circle around a planet, suppose this is the planet, and let's say this is the orbit in which the satellite is revolving. So satellite will have velocity tangential to the path, and this is the radius in which it revolves, x. With respect to center of the planet, the position vector of the satellite is already perpendicular to velocity. And if position vector is already perpendicular to velocity, you can directly write angular momentum as mvr. It's actually mvr perpendicular or mrv perpendicular. Here v and radius are already perpendicular to each other. So you can use mvr. Therefore, angular momentum of A will be mass of A, that is m1, speed of A. Okay, speed is not known, but radius of circular orbit is known to us, no? So we can express speed in terms of radius. Root gm by r1 multiplied with r1. So that is the angular momentum of A. Similarly, angular momentum of satellite B will be m2. Speed of satellite B can be written as, not satellite, these are planets. Okay. So root gm by r2. Here, capital M becomes mass of the sun. Like in case of satellite, we write orbital velocity as under root g capital M by the radius, where M is the mass of the planet around which the satellite is revolving. If you use the same equation for a planet around the sun, then M becomes a mass of the sun. Okay, planet mass won't be seen in this equation. I mean, orbital speed won't depend on planet mass. Multiplied with R2, and angular momentum of A and B are given L and 3L. So this is given as L, this is given as 3L. Divide these two equations, you will get m1 by m2 in terms of r1 by r2. Okay, and once you get that, substitute it here. You can tell the ratio of time periods in terms of masses. Okay, so you need to know how time period, like to answer this problem, you need to know how time period depends on radius. And after that, it's just some mathematical adjustments that you need to do. Okay, next problem. Try this. Okay, this is actually fine. I'll remind you what it is based on. They're asking you to consider the Earth as a sphere. A body weighed 300 Newton on the surface of Earth. Means on the surface of the planet, its weight is this much. How much would it weigh at r by 4 depth under the surface of Earth? So can any of you quickly tell me what concept this is based on? Like which part of this chapter is this based on? Weight on the surface and weight at a depth. Where have we discussed about all this? Okay, it is related to gravity at a depth. Gravity on surface, gravity at a depth. Based on that, you can tell weight. Okay. Try this, all of you. I'll give you all 2 minutes. Yusuf, tell me, what is the formula for acceleration due to gravity at a certain depth below the surface of the planet? No response. Pawan?
Sir, GM by R square.
Eh? I'm asking gravity at a depth below the surface. No, మరి depth terms లో ఉంటుంది కదా. How can it be independent of d? Gm by r square is gravity on the surface of the planet. Okay, anyway, looks like you all are not in touch with the formulas at all. So it is gravity on the surface into 1 minus d by r. See, these derivations are important. Okay, not just this formula, how this formula is derived is also important. Anyway, see, weight anywhere is basically mg. So if you want weight on the surface of a planet, it will be m into gravity on the surface of the planet. If you want weight at a certain depth, then it will be m into gravity at the certain depth. That's all. They have given this as 300. They are asking you how much is this. Okay. So we need mass multiplied with gravity at a depth. That is mass multiplied with gravity on the surface into 1 minus d by r. And what depth have they given? R by 4. So this becomes 1 minus 1 by 4 is 3 by 4. So 3/4 of weight on the surface. Weight on the surface is 300. 3/4 of 300 will be 75, 75, 75, 225. Vanilla, what mistake have you made?
God.
Okay,
So
you
like
took
if I
distance.
got to the calculations of
Fine, fine. Next problem. We go through this, all of you, ask if you have any doubts. See, you can't say you forgot the formula. I'm telling this to all of you. Like, I'm not asking you to recollect and do, no, you can refer to your notes now if you have, or it'll be there in the textbook. I mean, you should definitely maintain notes. If you don't know the formula, it doesn't mean you just don't solve the problem. You refer to the notes, get the formula, and solve the problem. Okay, now itself you could have referred and solved. Okay, next problem. Right. Try this, all of you. I'll give you 2 minutes. This is easy. Okay, I got one answer as A, one answer as C. Let's see. To project a body of mass m from the Earth's surface to infinity, the required kinetic energy is how much? Okay. This is a simple and straightforward question. If you remember the idea of escape velocity, it's even easier. To send something to infinity, you have to project it with a velocity equal to escape velocity or greater than that also. Okay. Actually, they should have asked minimum required kinetic energy, but that's okay. Now, escape velocity, the formula is under root 2 gm by r. In terms of, they are expecting the answer in terms of small g. That's the only thing you need to be careful about. And what is small g? Small g is gm by r square. Okay. So inside this bracket itself, multiply and divide by the radius of the planet. Gm by r square can be written as small g. So escape velocity can also be expressed as under root 2 small g r, where small g is the acceleration due to gravity on the surface of the planet. Okay, then they're asking kinetic energy. Kinetic energy is half mv square. 2 cancel, answer is mgr. Next question. Okay, next is related to satellite and geostationary satellite. Try this. Okay, they have used some term here. A satellite revolving around a planet in stationary orbit has time period 6 hours. Mass of the planet is 1/4 the mass of Earth. What is the radius of planet? Okay. Radius of geostationary orbit of Earth, they have given 42,000 kilometers. That's okay. And they said they have given mass of the planet 1/4 that of Earth. They're asking the radius in which it is revolving. They have given time period also. Okay. So I don't think you need to bother much about this term stationary orbit. Okay. Just an orbit. Fine. Try this, all of you. Okay. I got one answer as option C. Let's check. Now they have given radius of geostationary orbit for Earth. Fine. And they are asking a satellite is revolving around some planet with a time period of 6 hours. And they are saying mass of the planet is 1/4 the mass of Earth. What is the radius of the orbit? Okay. How are time period, mass of planet and radius related? Direct time period formula. Time period is 2 pi under root g mp, mass of the planet, divided by, okay, wait, 2 pi root x cube divided by gm, where m is the mass of the planet, x is the radius of orbit. Okay. They have given time period as 6 hours. Now substituting 6 hours in this doesn't make sense, and you don't have to also. Okay. I mean, substituting 6 hours is necessary, but calculating it based on this formula is not necessary. You can write 6 hours is equal to 2 pi under root x cube divided by g, mass of the planet. And they have given radius of geostationary orbit for Earth. Now, geostationary means what? The satellite's time period should be equal to the time period of rotation of the planet. We know Earth's time period of rotation is 24 hours. So for a geostationary satellite around Earth, the time period has to be 24 hours. Should be equal to 2 pi under root. Geostationary orbit radius they have given 4.2 into 10 power 4. This is in kilometers. Okay. Cube divided by g into mass of Earth. That's all. Now you divide these two equations and then make some adjustments. When you divide these two, 6 and 24 will go 4 times, 2 pi cancel. G, and they said mass of planet is 1/4 the mass of Earth. So you can say Earth is 4 times heavier than the planet. Okay, you can write it that way. Then square on both sides. Left hand side you have 1/4. When you square it, it becomes 1/16 is equal to right hand side. You have x cube. This 4 will go to the numerator here into 4 divided by 4.2 into 10 power 4 whole cube. Okay. So after that, it's all mathematics. X cube is equal to 4.2 into 10 power 4 whole cube divided by 16 into 4. 16 is 4 square, into 4 becomes 4 cube. Okay, there's an advantage in writing it this way. 4.2 into 10 power 4 divided by 4 whole cube it becomes. And 4.2 divided by 4 is 1.05. 1.05. So the answer is 1.05 into 10 power 4. Aishwarya, what mistake did you make?
Sir, I wrote the wrong time period.
Okay, okay. So this question is just based on time period of revolution of a satellite around a planet. Okay, we'll solve one more problem. Just a moment. See, according to Newton's law of gravitation, the gravitational force between two point masses is g m1 m2 divided by the square of distance between them. Based on this, we derived a formula for work done by gravitational force, and from that we got potential energy as minus g m1 m2 by x. Okay, so if this is the force, then this is the potential energy. Okay, so sometimes they ask you questions like this. Suppose gravitational force was proportional to 1 by x cube, then what will the gravitational potential energy be proportional to? Okay, how do you approach such problems? Without knowing the derivation, you can't do anything. You should know how to relate force to potential energy. From force, you calculate work. From work, you calculate potential energy. Okay, doing that, see, in the calculation of work done involves integrating force with respect to displacement. So 1 by x cube, if you integrate, okay, it's like x power minus 3. If you integrate, this becomes x power minus 2. So work done will be in terms of x power minus 2. That is 1 by x square. And if work done is in terms of 1 by x square, potential energy also will be in terms of 1 by x square. Okay, that way you can answer such problems. Next. Okay, try this question. This is also based on satellites. From exam point of view, satellites seem to be like their favorite topic. Okay, try. I'll give you all 3 minutes. Read the question carefully. Visualize what they are talking about and then write equations and solve. Answer is in terms of R. Any answer, anyone? They said there are two satellites revolving in different circular orbits. Okay. Just visualize what is happening. Okay. Height of one orbit is given r by 3. Height of the other orbit is not given. Okay. Planet radius is r. Okay. Let this be the orbit P. Let this be Q. Then this height is r by 3. Okay. They are asking how much is this height. So basically you need the other orbit radius. From that you can tell the height. What have they given? The accelerations of P and Q due to Earth's gravity, okay, are Gp and Gq, and they have given you the ratio. So P is here, it will experience some amount of gravity. Q is here, it will experience an even lesser amount of gravity. That ratio is given to you 36 by 25. This is a very easy question. I'll give you all 1 more minute, try to solve. Okay. And I got one answer as 3r by 5. Let's see. 3r by 5 is there in the options. So they gave the ratio gravity at P to gravity at Q. Now P and Q are both outside the Earth, outside the solid sphere. Then gravity outside a sphere is gm by x square. Okay. We know that acceleration due to gravity is nothing but gravitational field. Gravitational field outside a sphere is same as that of a point mass gm by x square. So gravity at P to gravity at Q, the ratio will be gm by radius of P. Now height of P is r by 3. Radius will be r plus r by 3, 4r by 3 whole square, divided by gm by radius of Q. Let's keep it as x itself. That's all. From this you will get the ratio. This is given 36 by 25. Now 36, 25, looking at those numbers, you should get the idea that squares are involved. Just a moment. There is some problem with my system. Okay, are you able to see my screen?
Yes.
Right. So GP by GQ is given 36 by 25. So they are squares, perfect squares. Now on the right hand side, you can cancel GM, and the right hand side would be x square divided by 4r by 3 whole square. Now you take square root on both sides. That's all. 36 by 25 square root becomes 6 by 5. Right hand side, you will be left with x divided by 4r by 3. 3 goes to numerator, 3x by 4r. So x becomes 6 into 4, 24r divided by 5 3s is 15. What is x now? X is the radius of the orbit in which Q is revolving. But we want height. So you have to subtract Earth's radius from it to get the height. So height in which Q is revolving is 24r by 5 minus, 24r by 15 minus r. R can be taken as 15r by 15. So that becomes 9r by 15. 3 3s and 3 5s. 3r by 5 is the correct answer. Okay. So all the questions before this were JEE Mains previous year questions. And this one is a JEE Advanced previous year question. But you must have noticed that these are not difficult, not very difficult to solve. Okay. You just need to know the concept thoroughly and apply it. Okay. No extraordinary thinking is needed. These are normal questions only to be solved by normal students. Okay. So if you are thorough in the chapter, you will be able to solve questions in the exam. That is what I wanted to make you understand. Okay, we'll stop it here for today.